Okay, so the next thing we're going to talk about as it relates to radicals is something called complex numbers. And this is the part of the class where I reveal to you that I have been lying to you for quite some time.
Oh, really? Why do you hate me?
Because every time...
That's not a real number.
Yeah, every time we've had something like this, square root of a negative, what have I always said? It's not a real number. And that's true.
But
It's not a real number. What hasn't been true is that I have told you to just write not a real number as your answer because you can't do this.
now you keep.
Well, today's the day that I finally revealed that in fact you can do this. It turns out you can take the square root of a negative. I'm sorry that I lied and misled all of you. So what we're going to do is we're going to split this square root apart, kind of like we do whenever we're trying to take the square root of a really big number and we split it into a perfect square and the rest. We're going to do something similar, except we're going to separate the number 36 from the negative. And the reason that we're going to do this is because although I cannot find the square root of -1 for like 30 more seconds, I can find the square root of 36, which is 6. Okay. So the square root of -1 is clearly the problem, right? It's not a real number. It's not a real number. That doesn't mean it isn't a number. It just means it's not a real number. In fact, it is a imaginary number. When we have the square root of -1, we write the letter I for imaginary.
Is that it?
Yeah, the calculator says error.
I times, yeah, calculator's not going to save you. I times 6 is fine, so is 6I. Thus, it is now possible for you to do the square roots of negatives. I know well, this is literally the first one, so calm down, it's coming. I thought this was going to be hard, but after one problem, I've got it.
I thought we were going to have to do like more math, but we just have to put I.
You are going to have to do more math, yes.
Yeah, because there's no square root.
So this one's not a perfect square, but we still separate it. Square root of -1 and the square root of 5. Now the square root of -1 we just said is I. The square root of 5 cannot be simplified. 5 is a prime number. This is the best we can do. So square root 5, done, answer. Okay, you want to see something really upsetting?
No, show me.
Negative square root of -20.
Okay. So does that make it positive?
Right?
It does not. So it's the negative is a -1 times, and then we're going to separate this, the square root of -1 times the square root of 20.
So it's a 1i 20.
-1i, yeah. -1 times I. But 20 can be simplified. 2 square root 5. (20) is 4 times 5, and the square root of 4 is 2, so 2 root 5. Good. So really the question is, how do we put all this back together?
Can you multiply the -1 and 2?
Yes, and the I. So -2i root 5.
I don't understand the 2 and the root 5. So the square root of 20 is 2 squared.
The square root of 20 is equal to the square root of 4 times the square root of 5. And the square root of 4 is 2. Okay. All right, here we go. Now your instinct might be, well, we can multiply those together. -3 times -5 is positive 15. It's the square root of 15. No. No, not how it works. Can't multiply two non-real numbers together and get a real number. But we can simplify this a little bit. For example, the square root of -3 is I root 3. And the square root of -5 is I root 5. We did the square root of -5 just a couple of minutes ago up here at the top, so we knew that was I root 5, and -3 follows the same rule. I root 3 times I root 5. Okay, so next we can multiply these together. Now, I can't multiply two non-real numbers, two non-real roots together like this, but now they're not non-real roots. Root 3 and root 5, I can put those together. That's root 15. But what's on the outside? I times I, that's I squared. Believe it or not, I squared is actually a number. I squared, like it's a for real number. Because I squared is the square root of -1 squared. And what happens when you square something that has been square rooted? They cancel out and it's -1. So I squared times the square root of 15 is -1 times the square root of 15, or negative square root of 15.
Can't you put anything negative number in there and that makes it a real number? If you exchange -1 with like -5.
If it was the square root of -5 squared, it would be -5, yes.
Oh, okay. So you just get
Well, because that's what I is. I is the square root of -1.
But I can't be the square root of any other number.
Yeah, I is not the square root of -5.
Okay.
I is always the square root of
I have a
-1.
hard time understanding why it's -1. It just is.
No, it's the lowest root you can have is 1. The smallest root.
Okay.
You should just remove the negative to the outside and multiply that.
That's exactly what I was thinking. Just see how the negative goes out.
Yeah, that works if you're doing 2 negative roots times each other. It doesn't work if you're doing 3 negative roots times each other.
But it would work with another pair.
Sure, as long as there's only 2 of them that are both negative, yeah. Yeah, that's a handy little shortcut. It would only work with 1 negative root times 1 negative root. It wouldn't work with negative root times a third negative root. Then it doesn't work. But surely you won't have any like that. Except for this one.
Not in real life, just in this class.
Well, I mean, how much real life stuff do you get in this class? I mean, other than the fitness tips I give you, which is worth its weight in gold. I'll tell you the key. It's what works for me. I do 1 sit-up every day. In the morning I wake up, that's the first half.
So is it just going to be like 6i?
Yeah, the first one's square root of -36 is 6i. And the square root of -1 is I.
So it's 6i squared?
6i squared. I. What's I squared?
1.
-1?
-1. So that's 6 times -1, which is -6. Which would follow the shortcut that you said just a minute ago. Put the negatives outside and then just multiply them. It works when there's two of them.
So the negative 36 and the negative 1 is a positive 36. Squared is 6.
I don't understand anything you just said. Cool. As long as we're on the same page. Neither one of us knows what you're talking about. Does not work out quite as nicely when only one of them's negative. Hmm?
Or, yeah.
2.
2i.
2i.
Negative 2 would be.
No, it'd be I root 2.
Oh.
What about 8? Very good. 2 root 2. You are good at these square roots. So when I multiply these together, I have to keep the outsides and the insides separate. So on the outside, I have 2 times I. On the inside, I have 2 times 2. Right, square root of 4 is 2. So 2i times 2, which is? How about just 4i? It's not I squared because there's only one I. I know you were thinking to yourself, like, math is great and all, but you know what the problem is? There's not enough numbers. I mean, yeah, there's a bunch of real numbers. It's like infinity of them. But I wish there were more numbers. Well, good news. We've just doubled the amount of numbers available, because now for every regular real number, there's an imaginary number. I see your 4, and I raise you 4i. In case you were wondering, is it possible to double infinity? Yes, it is. We just did it. And they said it couldn't be done. So this one is a division problem, obviously, and so I want to see if you remember your division rules. First of all, on the top, that's going to be I root 125. And on the bottom, square root 5.
So does it say 125 because it's not a perfect square? Because I'm getting myself confused.
Yes, it's 125 is not a perfect square.
So it's saying
Right, but what I want you to remember is that whenever you're dividing radicals like this, we can put them together into a single radical, like that.
okay.
And that's helpful to us because what's 125 divided by 5?
5.
25. What's the square root of 25? So 5i. So far, so good? Well, that's multiplying and dividing. What's next? How about adding and subtracting? This is not that bad. All you have to remember is that the i's, even though they're not variables, work like variables in that you can combine real numbers with real numbers, and you can combine complex numbers with complex numbers, and never the two shall meet. So in this case, I can combine the 2 and the negative 3, which would give me, good, And I could combine the 3i and the 2i for 5i, but I can't combine these together. So that's it. It's exactly like combining like terms. The i's aren't variables, but they behave like variables. Let's do a subtraction. You got to be careful when you have a subtraction sign out in front of a set of parentheses. You got to be real careful because that's a distributive sign. It's a distributive property problem. It's -1 and minus -i. So this is going to give me 5i minus 1 minus -i is the same thing as plus I. When I combine my i's, what will I get?
6i.
6i.
Minus 1.
And that's it.
6i minus 1 is fine. Typically, when we write our answers, though, we write them with the imaginary on the end. So the most correct way to write this would be like that. Typically, just math convention. I don't think there's any really good reason for it other than that's what math people do, is they put the imaginary number on the end after the real number. And this is called, because people are so good at naming things, A plus BI form, which is a math nerd way of saying the imaginary or the complex number is tacked onto the end. Okay. It's not too bad yet, right? Right? Guys? Right? What about that one?
Distribute the negative.
Right, this negative gets distributed. So it will be -3 minus 7i plus 6. Combine the numbers, -3 and positive 6. 3. And then the poor 7i doesn't have any friends. Three minus 7i. Yes? No? Maybe?
It appears simple enough.
Well, just wait.
Ugh.
It does appear simple enough. We should do something about that. Guesses?
-21i.
That's a really good but
21i squared.
slightly wrong guess. That is a much better guess. You just multiply the numbers. -7 times 3 is -21. And then you multiply the i's. I times I is I squared. You should recall that I squared is a number. What number is I squared?
-1.
So this is -21 times -1, which is
21.
if somebody really wanted you to write this in A plus BI form, you could say 21 plus 0I. I feel like only a psychopath would ask you to do that. So be prepared for that on your homework.
Really?
Only a maniac would do that, so it will definitely happen to you. All right, what do you got there? I'm ready to hear something intelligent, although I will settle for something stupid.
6i.
Oh God, not that stupid. I'm just kidding, you're fine. That's 6i.
3i squared.
Minus, yeah,
Negative
minus
3i squared.
3i squared.
But 3i squared.
Yep, I times I squared.
Negative.
Yep, I squared is -1. So this is 6i minus 3 times -1, which is 6i plus 3. 6i plus 3 is fine, but we like to put the
3 plus
complex
6i.
number on the end, so 3 plus 6i is better. Okay. If you say foil, I'm gonna slap you.
You said them equal to 0?
No, you just distribute.
Thank you. The distributive property. Was that so hard, you foil maniacs? The what?
Those are fighting words.
Somebody just say it's the same thing. It's the same thing.
Minus 20i.
It's like when somebody tells you, I'm having such a bad day. When I was out in the parking lot, I got hit by a car. And you're like, girl, I know exactly what you mean. Because one time I ordered 6 nuggets and they only put 5 in the bag. So trust me, I know what you're going through. It's that kind of same thing.
Minus 20i.
Thank you. Minus 20i.
Minus 5i squared.
The same thing. All right. So we've got the parentheses taken care of. We've got the distributive property done, but we still have some heavy lifting to do here. One of the things we can do is combine these. What do we get when we combine those two? Good. And we could also do something with this.
5 times -1.
That's, yeah, minus 5 times -1, which is positive 5. So when I write this, I'm going to do 8 minus 18i plus 5. And then what?
Combine 8 and 5.
That's exactly right. The 8 and 5 can be combined.
15. That's fine.
So far, so good?
So far.
All right. So far. What did you say? Oh, you think something bad's going to happen soon? Nonsense.
You look like it counts, so.
What? Did you say I look like Ben Affleck? That's what it sounded like you said.
Mm.
I normally get Brad Pitt, but Ben Affleck did.
Funny they like.
They're like, do you and Chris Evans have the same personal trainer? Nope. I know it looks like it, but this is all homemade.
They lied to you.
What does it mean? Don't feel bad. I had to Google him. It's Captain America. What do we do? What does squared mean?
2 minus I times 2 minus I.
Yeah, times it by itself. Good. Okay?
Distributive property.
Distributive property. 2 times 2 is 4. Then I'm going to do these at once. 2 times negative I and another 2 times negative I is negative 4I. And then negative I times negative I is positive I squared. Okay?
So it's basically just literally the same thing with the variable stuff.
It's sort of like a variable, except now that we're to this point, there's an extra step. What's the next thing we do?
I squared is -1.
Yeah, I squared is negative 1.
It's 3 minus 4i.
Good, you even combined them. 4 and minus 1 is 3. Minus 4i. I. Let's do one more of these and then we'll see if we can really ruin your life. I feel like there's not enough wailing and gnashing of teeth and rending of garments right now, so I want you to know that you're bringing this on yourself. This one's actually kind of nice because they're exactly the same, only one's plus and one's minus. What's that called?
We learned it last week.
We did learn it last week.
Conjugate.
Conjugate, exactly right. Now the benefit to a conjugate is twofold. Number one, the multiplication's really easy, and number two, we're about to use conjugates in t minus 2 minutes. So when I distribute, I do 7 times 7, that's 49. And then I can ignore the middle section because 7 times negative 3i is negative 21i, and then 7 times positive 3i is positive 21i. So those are going to cancel out. Minus 21i plus 21i are going to cancel. And then negative 3i times positive 3i is minus 9i squared. That's really handy because 9i squared is a number. This is negative 9 times negative 1, which is positive 9. So what I have here is 49 plus 9, also known as 58. And that's it. That's pretty nice. I didn't even have any I's in my answer. One of the hardest types of these problems that you're going to do, though, are ones that do actually involve the conjugates. You will recall from last week's class that we learned how to rationalize the denominator. And the point of rationalizing the denominator is that you cannot leave an answer with something that has a square root in the denominator. This one doesn't look like it has a square root in the denominator, but it does. And the reason it does is because I is a square root. It's the square root of negative 1. So I can't write an answer that includes I in the denominator. So just like last week, the way I'm going to get rid of that is by multiplying by the conjugate. What is the conjugate of 1 minus I? Well, that'd be 1 plus I. But if I multiply the bottom by 1 plus I got to multiply the top by 1 plus I. So here we go, distributive property. The top's going to be the worst. 2 times 1, and then 2 times I, followed by 1 times I, so that's going to be 3I total. 2I plus 1I? 2 times I and 1 times I? I do it just for you. And then I times I squared. I'll clean that up in just a minute. Let's go ahead and take care of the bottom. Now the bottom, since they're conjugates, means I can ignore the middle stuff. 1 times 1, 1. And then this is the part I can ignore. 1 times I and 1 times negative I, those cancel, so I can ignore those. Positive I and negative I. And then I got negative I times I negative I squared. And I'll stop right there for a minute, let you catch up. A little bit of cleaning up to do here. I squared, of course, is negative 1. So on the top, the 2 and the minus 1 can combine. That'll give me 1 plus 3i. On the bottom, minus I squared means minus negative 1, which is plus 1. 1 plus 1 is 2. Let's see your fancy calculator do that. This one's actually really easy. How do I get rid of I? Well, I want to get rid of the I. The I is a square root. That's what I want to get rid of. What would I need to multiply by to get rid of the I? How about, I heard somebody say it, how about just I? And the reason that works is because 3i times I is 3i squared, which is 3 times negative 1, which is negative 3. Look, the i's gone. But if I multiply the bottom by I got to multiply the top by I. That's really easy, though. It's just 7i. That's it. That's a great answer. There's no i's in the denominator. That's what we wanted to do, right? Easy enough? So the last thing that we're going to talk about as it relates to complex numbers, not the last thing we're going to talk about ever, sorry, is finding powers of I. Okay, for example, I'm going to make a little table here. I to the first power is I. That should not come as a surprise to you. And we talked about I squared being negative 1. What is I to the third? Well, I to the third power would be squared times the first. It'd be these two multiplied together. I squared times I to the first is I to the third, right? That's how exponents work. You add the exponents. So something to the first times something to the second would be something to the third. So what's negative 1 times I? Well, that's negative I. What's I to the fourth then? I to the fourth is the same thing as I squared times I squared. What's I squared times I squared? That'll be negative 1 times negative 1, which is 1. When you're talking about powers of I, these 4 powers just repeat over and over again. What I mean by that is, if I kept going, I to the 5th. I to the 5th is equivalent to I to the 4th times I to the 1st. 4 plus 1 is 5. What's 1 times I? I. I to the 6th then is I to the 4th times I squared. 4 times 2, or 4 plus 2, really. 1 times negative 1 is negative 1. I to the 7th power is I to the 4th times I to the 3rd. negative I. I to the 8th power is I to the 4th times I to the 4th. 1 times 1, which is 1. I wonder, could you tell me I to the 9th?
1.
So no, you can't.
Okay, I to the 9th, I.
I. What's I to the 10th? What's I to the 11th? What's I to the 12th? What I want you to notice is that every time you have an exponent that is a multiple of 4, 4, 8, 12, all of them, the answer is 1. I raised to a power that is a multiple of 4, the answer is 1. So if I were to ask you, not that I ever would, to find something crazy like I to the 20th, yeah, 20 is a multiple of 4. 20 can be divided by 4. You could write this out the long way by saying this is I to the 4th to the 5th power. I to the 4th times I to the 4th times I to the 4th, etc. I to the 4th was 1, so this is 1 to the 5th power, which is 1. You don't really need to go through all that trouble if you see that 20 is a multiple of 4. Anytime it's a multiple of 4, the answer is 1. So what about if it's not a multiple of 4? What is the highest multiple of 4 that is lower than 46? 46 is not a multiple of 4.
40.
40? I can think of a higher one. 42 is not a multiple of 4. 44 is. So this is equal to I to the 44th times I squared. I to the 44th is 1. Anytime you have a I to the power that is a multiple of 4, it's 1. So this is 1 times I squared. Well, 1 times I squared is just I squared, right? And what is I squared? It's negative 1. What about that one?
Does it work the same way going the other direction?
Is negative 12 a multiple of 4? Yes.
Would it still be 1?
Yep. Doesn't matter if it's negative. Here's why this works. Let me show you the long way. Anytime you have a negative exponent, you move it down to the bottom to make it positive, like that. Since 12 is a multiple of 4, this would be 1 over 1, which is 1. And that's the last thing that you need to know about complex numbers.